This is LeetCode group anagrams. We're given an array of strings and we need to convert it to an array like this. We need to group all of the anagrams together in separate arrays. If we think about our brute force algorithm, we go through each element of the array and we check it with every other element in the array. So we would check these two, and we would check these two. But this is obviously a very slow algorithm. So how do we improve it? Well, the idea is to use a data structure to keep track of all the anagrams that we've seen so far. So the question is, how do we group anagrams together? We know two strings are anagrams if they have the same exact characters, although they could be in different order. So a simple way to check if two strings are anagrams of each other is to just sort the strings. So if we sort EAT and we sort T, AET and AET, and then we just check if they're the same. And of course they are. So here's the algorithm. We go through this array and the key of the dictionary is going to be the characters sorted. So it's going to be AET and the value will just be an array of EAT. Okay, then we get to this T here and we say, okay, we sort this and we see it's already in the hash. So we just add it to this array here. And then we get to this NAT and we see, okay, well, it's not in this hash. So we got to add it to the hash. And that's it. So we just went through the whole array and we created a hash where the keys are the sorted strings and the values are just the strings themselves. And all we do is we return an array of all the values. In terms of complexity, this is O of n, where n is the length of the whole array times k log k, where k is the length of each string because we have to sort the string and that's an n log n operation. In terms of space complexity, the absolute worst case is if we had a separate key for each of the strings. So it would be 2 times the number of strings in the array, which is just the number of strings in the array, right? So it's going to be O of n. Now the question is, can we get to an O of n times k algorithm? And of course the answer is yes. So instead of sorting each string, we can actually create an array length 26 where each element in the array represents the number of characters for that letter. So we get to this E, right? And it would be an array of 0, 0, 0, 0, etc. This is length 26. We know each character of each string is a lowercase English letter. That's why it's length 26. And so, okay, we get to this E and now we just add 1 at position 5. We get to this A, we add 1 to index 0, and then we get to the T and we add 1 to wherever the T is in this array. And so we do the same exact algorithm, but we just use this instead of the sorted string for the key in the hash. So it looks something like this. Here's the A, here's the E, and so on, right? And this would be a key, and this would have EAT and T. There would be another one where it would be, 1 for the A, and then it'd be a bunch of zeros, and then 1 for the N, 1 for the T, and this would have NAT. Again, for space complexity, it's O of n, because the data structure that we're storing is worst case going to just have all the strings in it. And then the time complexity is actually going to just be O of n times k, because we're going through all of the strings and we're just going through all the characters in each string. Now, before we get to the code, if you found this helpful so far, please give a like and a subscribe, because it really helps the YouTube algorithm. Okay, first thing we do is define our data structure. We'll call it anagrams. And for each string in strings, now we have to create our counts array. So it's going to be an array of zeros of length 26. And then we'll say for each character in string, now we want to add 1 to the index of the character in the counts array. And the way we get the index is by getting the integer value of the character minus the integer value of A, because A is the first index. So it's basically just shifting our integer value down. And then we just add 1 to this. And then we just have to add the string to our data structure. We say anagrams at counts, append string, and then we return anagrams.values. Now, 2 things that don't work here. First is that we can't use a list for the key in Python. We have to use a tuple. So we'll just convert this to a tuple. And the other thing is this won't work because this won't be defined at all. So instead, we can just use collections default dictionary, and we'll use a list as the default. So now even if this isn't in the hash yet, it'll just return a list and we can append to it. And boom, that's it. And if you found this helpful, please give a like and a subscribe because it really helps the YouTube algorithm. And I'll see you next time.